Mrs. Cameron here. I wanted to show you that for our Algebra 1 Best EOC packet, the yellow packet, that pages 1 through 7 are covered here. Here's the link to the practice again, and you have a link to a PDF of my PowerPoint of me solving those 13 questions. And the PowerPoint is here. I know in class some people were having difficulty downloading the PowerPoint, and so I'm just going to go to the PDF here. Cover page, things you need to practice, have your packet, whatever you're watching this on, a calculator, some scrap paper, pencil, something to write with. Here's a link to the practice questions. Make sure you know how to find the reference sheet online, how to pull up the calculator online. For right now, you should be using your reference sheet in your packet all the way through your test. Make sure you're comfortable using the calculator. Let's see. Question number 1. Doug has 8 square pieces of wood. Each piece of wood has a side length of S centimeters. The total area of all 8 pieces of wood is 200 square centimeters. Create a quadratic equation Doug can use to find the side length of each piece of wood. Always first step is marking up our keywords and read the directions and pick out the keywords. You can use the highlight feature on the testing app platform to do that. Step 2, we're going to use our keywords to write a quadratic equation and visualize what's going on. A quadratic equation just means that there is an equation that has a variable in it that is squared or has an exponent. So my notes here that you can actually see, sorry about the last video. We have a square, and the area of a quadrilateral is base times height. So the area of a square is side times side, or side squared. And since we have 8 pieces of wood, we have S squared times 8, or 8S squared. And the last piece of information, our keyword is or was. Is tells us that we have an equal sign. So we know that 8S squared equals 200, which is the total area. And that was what you type in for number 1. Looks like my equal sign didn't go through on this. There should be an equal sign right in between those. Question 2. A band sells X amount of premium tickets and Y regular tickets for a concert. A premium ticket costs $20. A regular ticket costs $5 less than a premium ticket. The band raises $2,145 from selling tickets. Select coefficients to complete the equation representing the relationship between X and Y. And for me, again, my first step on this is to use the highlight feature on my keywords. And since there's 2 variables given in that first sentence, I'm color coding the information for each variable. And It says to select coefficients for each variable. Coefficient is just the number in front of the variable. If a premium ticket is $20, I know that a regular ticket is $15 because $15 is $5 less than $20. So I'm ready to answer this answer just after highlighting keywords. So it's 20x plus 15y equals 2,145. And then question number 3, how would you solve it? Enter an expression to make a true equation. On this one, when we looked at this in class, we said that this is a type of factoring that looks like an easier question that we know, which is factoring with a special case. Having those 3 variables at the beginning, I said for me it looks a little scary with all of those variables together, but at the same time it looks similar to something simple that I know. So I tried putting XYZ in place of a plain X, or a plain X in place of the XYZ. So I said that I know X plus 1 times the difference of X and 1 makes the middle cancel out. That turns to X squared minus 1. So I can multiply using the distributive property over on this side, first, add, or inner last, or I can model using the area model down here in my orange and blue. Either way, I got the same answer. And then I applied the same thing we did here with this X plus 1, X minus 1 to XYZ plus 1, XYZ minus 1. And I got XYZ squared plus XYZ minus XYZ minus 1. The middle canceled out, so when you bring it down, it's just XYZ squared minus 1, which worked. So entering an answer for number 3, it was just XYZ plus 1. And then question number 4, how would you solve this? A function is shown, f of x equals 2x plus 1. Select all the effects on the graph of the function f of x when it's multiplied by 3. The x-intercept increases, the x-intercept decreases, the y-intercept increases, the y-intercept decreases, the slope increases, the slope decreases. I said for me, I'll make a table, so I want to know those 3 things about function 1. What are the y-intercept, x-intercept, and slope? Same thing for function 2. What is the y-intercept, x-intercept, and slope? So function 1 was the original equation, y equals 2x plus 1. Function 2 is multiplied by 3, so I put my 3 outside of parentheses, then I use the distributive property. 3 times 2x is 6x, 3 times 1 is 3, so function 2 turns into y equals 6x plus 3. Right away from looking at this, I have my slope and y-intercept in the formula. So I know on function 1, the slope is 2, because there's a 2 in front of the x. I know my y-intercept is 1, because there's a plus 1 on the end. And in order to find my x-intercept, I have to do a little bit of work. I have to make my y, or my function, equal to 0. So I put 0 equals 2x plus 1. First step, I subtracted 1 on both sides, and that gave me -1 equals 2x, and then I divided both sides by 2 to give me -1 over 2 equals x. So that was my x-intercept for function 1. And for function 2, I did the same thing. My slope was 6 because that's what is in front of the x. My y-intercept is 3 because on the end of my equation I have a +3. Y equals mx plus b plus 3. Y-intercept is 3. So to find the x-intercept, I had to make my y equal to 0. So 0 equals 6x plus 3. Then I subtracted 3 on both sides, which gave me -3 equals 6x. Then I divided both sides by 6. That gave me -3 over 6 equals x. And this fraction can be simplified because 3 and 6 can both be divided by 3. So my x-intercept simplifies to -1/2, which is the same thing that I got for function 1. So both functions have the same slope. So I put that into my my table, and I can easily compare my y-intercepts and see that the y-intercept went up. It started at 1, it went up to 3. My x-intercept started at -1/2 and it stayed -1/2. My slope started at 2 and then it moved up to 6. So I can fill in the table, compare the functions in the table to answer question 4. Remember the rule for answering multi-select questions like this. It's never just one answer and it's never all of the answers. So what happened to the x-intercept? It stayed the same, so it was neither of these answers, but the y-intercept increased and the slope increased. So we had 2 answers for number 4. And now moving on to question 5, where would you start on this? It says the equation for the function f is shown. F of x equals -1/2 x plus 3. The quadratic function g has the following properties. G has a lesser y-intercept than f. The maximum value and y-intercept of g are not equal. First, g increases and then it decreases. Drag the vertex and y-intercept labels to show possible locations for the vertex and y-intercepts of g. So again, I start with keywords here, and I can see they gave me an equation for a linear function like y equals mx plus b. Here, my f of x equals -1/2 x plus 3. The question is asking me to graph 2 key features of a quadratic function, g. The third bullet point of information in the question is really just extra information, or maybe they're trying to be nice and remind me that a quadratic function looks like the letter U or N when graphed. Since the y-intercept of my linear function f is 3, the y-intercept of my quadratic function can be anywhere on the y-axis that is below the 3. So for this, it would need to be 2 or 1, 0, -1, anywhere below the 3. The maximum value or minimum value of a quadratic function is where the vertex is. So that's the very, very top or the very, very bottom. Since this one's going to have a maximum, it's going to be the top of the graph. So I can put that point anywhere on the graph that is not on the y-axis and is above my point for my y-intercept, and it'll be correct. So there's, I don't know, probably like 100 correct answers for this particular question. So for B, I just put my y-intercept here at the 1, but it could be anywhere below 3. It could be at the 2, 0, or any of these negative numbers. And your vertex just needs to be above the y-intercept. So your answer may look very different from mine, and we could both be correct as long as the y-intercept is on the y-axis and below the 3, and the vertex is on the y-axis, and the vertex is not on the y-axis, but above the point for the y-intercept. So here's some more answers that could be correct. So we've got a y-intercept that's negative, and the vertex is above. So our function would be this n like this, or like this, or like this. Okay. And here's some more information about quadratic functions that I think about when I read the word quadratic function or look at that part of my reference sheet. Being able to remember this information will help you answer some of the more difficult questions on your Algebra 1 and, of course, exam. I copied the formulas from the reference sheet. Do you know where to find this on your reference sheet? Right? Forms of quadratic functions. F of x equals ax plus bx plus c. That's our standard form. One thing that you have to memorize is the formula for the axis of symmetry, where x equals b over a times negative 2. This is also going to be your x value of your vertex. When you're in standard form, this c is also always your y-intercept. And quadratic functions look something like I said, like a u or an n. And this first one, this axis of symmetry is at x equals negative 3. The vertex, we could say it's at negative 3, negative 12. And if we had a y-intercept of 0, 4, I know my y-intercept is 4, and my b over a times negative 2 equals negative 3. So I can find my equation from this information by making b 6 and a 1 to make b over a equal to b over a times negative 2 turns into 6 over 1 times negative 2, which equals negative 3, which is our axis of symmetry. So f of x equals x squared plus 6x plus 4. Sorry, those symbols didn't carry over to the PDF. Some things got dropped off. Quadratic function over here, we have our maximum at 5. Our vertex is negative 15, 5. And our axis of symmetry is x equals negative 15. Our y-intercept is at negative 10. And for this quadratic function, I know the y-intercept is negative 10, and b over a times negative 2 equals negative 15. So I can find my equation from this information. So we made a b 30 and a 1. So 30 over 1 times negative 2 equals negative 15. So this function equals, f of x equals x squared plus 3x minus 10. And again, sorry that some of this stuff got cut off when I converted it to a PDF. Question 6, where's the best place to begin looking at this question? The expression 15,000 times the sum of 1 and 200 to the power of m can be used to model the sales in dollars of the company after m months. The value 12 was substituted for m to create the expression 15,000 times 1 plus 200 to the power of 12. Enter a number and select a unit to complete the sentence. The expression 1 plus 200 to the power of 12 represents the growth factor of the company's sale for a period of time lasting, and it wants you to fill in how long. And by looking at my keywords, I know that M is for month, and they put in a 12 for the M, so that's one correct answer for this question. It's a period lasting 12 months. We also have 1 year could be correct, or 365 days could also be correct for question 6. Question 7. What's the first thing you would do here? A table of values for a linear function is shown. X, negative 1, 3, 6. F of x or y is negative 8, 0, 6. Match each key feature of the graph to its value. And I can see right away that when y is 0, x is 3. So I know that my x-intercept is given at 3. I got 1, so I just eyeballing it. And now to find the rest, I would draw a graph for this. So that's what I did when I was solving. And even though I didn't graph it perfectly straight, I think I can find all my answers just from a quick sketch. And again, x-intercept is 3. That's on the graph. I can also see my y-intercept is a negative number, and mine is going right through the negative 6 here for my y-intercept. Even if my drawing's a little bit more wobbly and not lined up, negative 6 is still the only one of my answer choices that's close to what's on my graph. And then finally, I can count my rate of change, which is really another name for the slope on the graph between 2 points. If I start at 3, 0, I can count that I go up 6 units and write 3 units to my next point. So that would give me a slope of 6 over 3, which is a fraction. And I say this all the time, every fraction is what kind of problem? It's a division problem, so 6 divided by 3 is 2. So my rate of change on my slope is 2. So I just put those answers in the boxes, and when you have a table like this to fill in, write only one answer per row. So you can only have one x-intercept on a linear function, one y-intercept on a linear function, and only one slope for a linear function. And then moving on to question 8. This is a 2-part question. Make sure you scroll down and start thinking about how to solve the whole question. The fuel economy of a car is its average distance traveled per amount of fuel consumed. Cars have different fuel economies when they are driven in the city and on the highway. A linear model of the relationship between the city and highway fuel economies of 8 cars in miles per gallon is shown. This question has two parts. Part A, which linear equation best models the scatter plot? And then part B, based on the model in part A, what could be the highway fuel economy in miles per gallon of a car that has a city fuel economy of 43 miles per gallon? Round your answer to the nearest hundredth. So for me, I'm going to start imagining where my line of best fit is for my graph. You can't use a tool to draw on the screen for this in the test, but you can take your pencil and put it up to the screen and line up where your line would be. So I chose this line here because I could see like just about the same amount of points on the line, above the line, and below the line. So to me, that looked like a really good line of best fit. And I can see 3 points that make sense and line up as whole numbers on my line of best fit on this scatter plot. I got 3240, 3643, and 3945. I can figure out my slope by counting up from 3643 to 3945. I go up to, right, 43, 44, 45, up to, and I go right 3, 36, 37, 38, 39, up to over 3. So that makes my slope 2 over 3. And really done with part A right now because there's only one equation with my exact slope. However, the slope for answer choice B is close to being an equivalent fraction, so I can double check my equation using point slope formula from my reference sheet. So here's Mrs. Cameron being extra careful to check my answer in part A. There's my point slope formula for a linear equation. And since I know that the slope is 2/3, I can pick any one of my 3 points from my line of best fit, and I chose 3240 since those were the smallest numbers. And then I plugged it in. Y minus y1 equals m times x minus x1, plugging in 2/3 for the m and plugging in 3240 for x1, y1 respectively, which gave me y minus 40 equals 2/3 times x minus 32. Step 1, moving forward, is to get my equation from point slope format to slope intercept format like my answer choices. So I distributed my 2/3, which gave me y minus 40 equals 2/3 x minus 2 times 32 over 3. And then I added 40 to both sides, which gave me y equals 2/3 x minus 64 over 3 plus 40, which simplified to about 2/3 x minus 18 over 6 repeating, which was super close to 19, just like answer choice A. So I got my answer. Part B was A. Part A was A for number 8. And now looking at part B, I'm plugging in 43 for the city fuel economy to find the highway fuel economy. And by looking at my graph again, I know that the city fuel economy is my X value and the highway fuel economy is my Y value. So I can use my answer from part A to plug in 43 for the X, which was the city fuel economy, to find Y, the highway fuel economy. So I color-coded to keep my X's and Y information straight. And that's what I did. I plugged in 43, and then I used a calculator to solve and simplify this out, which gave me y equals 46.6 repeating, and the question said to round the answer to the nearest hundredth. So the hundredth place is 2 places behind the decimal. So my repeating 6 tells me to make my last number a 7 because 6 is 5 or more, telling this 6 in the hundredth place to go up by 1 more. So I put in both answers. Answer after carefully reading that the answer for part B needs to be rounded to the nearest hundredth. Your decimal point must be in the correct place or your answer is wrong, and you must have the correct amount of numbers behind the decimal to be in the hundredth place or your answer is wrong. Oh look, and I typed it in wrong. Should have been 46.67 and I typed 47.67. Mrs. Cameron would have had that wrong right there. Mathematician, you should have tended to better precision. That should have been 46.67, not 47.67. Oof. Don't pull a Mrs. Cameron and do all of that work and then type your answer in incorrectly. Wowzers. Number 9 also has 2 points. This Giselle has 40 prizes for raffle ticket winners. She gives away 2 prizes each day until she runs out of prizes. The equation P plus 2T equals 40 represents the situation where P is the number of prizes Giselle has left after T days. First, select P or T to represent the independent variable, then use the add arrow tool to graph the relationship. Part B, enter a value in each box to describe the relationship. The domain of the relationship is from blank to blank, and Giselle will give away all of the prizes after blank days. How would you start to solve this question? For me, I'm going to highlight my keywords again. Giselle has 40 prizes for raffle ticket winners, gives away 2 prizes each day. P is the number of prizes. T is the amount of days. Part A, select your independent variable. And for me, I know that T will be the independent variable because T is days and days are time. And time is just always the independent variable. It just is. That's been a hard rule in graphing since you were a 5th grader. I know that because I taught 5th grade. I know. Love saying that all the time. So my independent variable is T. And then I can graph the situation. So I highlighted T for my independent variable, and I put my independent variable as my X, always, and then P for my Y variable. And now that I have my independent variable, time and days, on the graph for X, I can use my highlighted keywords to graph my line. So we start with 40 prizes per day, so that's my y-intercept and the start of my graph. And I can continue my graph by thinking about giving away 2 prizes each day. So as y goes down by 2, x goes up by 1, because we're giving away, so there's 2 less prizes every day. So 40, and then she's giving away prizes, so that her time is 20 days. She's out of prizes after giving away 2 prizes every day. And then part B, I know that the domain is all of my X values. I know because the keywords domain and range go together, and that domain is X because domain comes before range in the alphabet, like X comes before Y in the alphabet. That's my trick for remembering domain and range. So my domain is from 0 to 20 on my graph, right? My X values, my T values go from 0. She could have 0 days up to 20 days. So my domain is from 0 to 20. This means Giselle is all out of prizes in 20 days. So I was able to graph those. Domain 0 to 20. Giselle will give away all the prizes after 20 days. That's done. And then question number 10. A school office surveys 6th and 7th grade students about whether they ride the bus to school. The data are recorded in a frequency table. Enter numbers to complete the frequency table for the data. So we've got 6th graders, 7th graders, and total students who ride the bus or do not ride the bus, and the total amount of students. I'm not sure how you would solve this, but for me, I'm going to go straight to my calculator to add and subtract to fill in the table. And I know that 176 plus 74 equals 250 total 6th graders. 400 minus 128 equals 272 total bus riders. 272 minus 176 equals 96 7th grade bus riders. And 128 minus 74 equals 54 7th graders who don't ride a bus. I'm going to enter my values and then double check on my calculator by adding up the columns and rows. How much time do you get for this test? Right? All day. So take the time to double check. Don't pull a Mrs. Cameron and make a goofball mistake. So 176 plus 74 equals 250, check. 96 plus 54 equals 150, check. 272 plus 128 equals 400, check. That's the rows. Now the columns. 250 plus 150 equals 400, check. 74 plus 54 equals 128, check. 176 plus 96 equals 272, check. Checkity, check, check, check. Make time to check your answers. Question 11, what would you do first? A system of inequalities is shown. Inequality number 1, y is less than negative x minus 1. Inequality number 2, y is greater than or equal to x plus 1. Select a solid or dotted line, boundary line for each inequality. Click in a region to graph the solution set of the system. And we've been practicing this a little bit in class. Our inequalities, right? So which of these gets a dotted and which gets a solid line, right? And this question, as soon as you click on your dotted or solid line, it puts the graph down for you. You don't have to graph the inequality. So those are the key words, right? Solid and dotted boundary lines and the region for the solution set of the system. I know solid lines are for, it took off my little lines down there. Solid lines are for less than or equal to or greater than or equal to. The little line should be underneath here. It doesn't carry over on my PDF with the line at the bottom, and are set as less than or equal to and greater than or equal to. I know that less than, greater than are just less than or greater than. I also know that y is less, so shade below, and y is greater, shade above. So my y is greater than or equal to x plus 1. I made yellow, and that is my solid line. The yellow got the solid line because it has the little bar underneath here. And then I would shade above on this. And then the other equation, y is less than negative x minus 1, is a dotted line because we don't have that line underneath our inequality. And since it's less than, we shade below the graph. And the solution set is the stuff over here that got shaded twice by both inequalities. Since we have a system of inequalities, the answer is the stuff that gets shaded twice. And so that's what I entered for my answer. So inequality number 1 was the dotted line, inequality number 2 was the solid line, and over here, this portion in quadrants 2 and 3 is the solution to the inequality. And then number 12, what is the best place to start? A table shown represents two functions, function A and function B. Complete the sentences to compare the two functions. Function A appears to grow blank. Function B appears to grow blank. As x increases, the quantities for blank will eventually exceed the quantities for blank. And when you look at the drop down, you will see that it's going to tell you either linear or exponential. It's not making you also compare quadratic functions, only linear versus exponential. So where would you start to figure out this question? For me, I would compare what's going on in the two sides of my table using a calculator. So function A is my blue notes over here, and function B is my orange notes over on this side. And I can see that x is not going up 0, 1, 2, 3, 4. It's going 0, 1, 10, 20. So it never goes up the exact same amount. But for function A, from 0 to 1, it goes up by 50. From 1 to 10, we go up from 750 to 1200, which was 450. And since x went up by 9 times 50 is 450. And from 10 to 20, we went up 10 times 50, it's 500. So A is linear because it's always going up by 50. And B goes up, the first time it goes up 24, and then it goes up 9 times how much? It goes up 9 times 44, which is not the same as my first amount. And then my next amount, it goes up by 10 times 42.7. So B is exponential because it's not going up at a constant rate. And question A, I know that A is linear from my notes and B is exponential. I can assume that the values for B will eventually exceed A just by the way the question is worded, really, right? The values for A already exceed B. The way the question is worded tells me that there's going to eventually be a change. So I put in function A appears to grow linearly and function B appears to grow exponentially. As x increases, the quantities for B will eventually exceed the quantities for function A. And that's correct, not only just based on how it's worded, but also based on exponential functions always overtake linear functions in the long run. And then I gave you some of my notes for an exponential function. I think about all of this when I see an exponential function or when I look at this spot on the reference sheet. If you can remember this, you can get some of the hardest questions on the test, right? So forms of exponential functions. F of x equals ab to the power of x. This is my go-to spot on the reference sheet for exponential functions. F of x equals ab to the power of x, where a is your y-intercept, and b tells me if my exponential function is increasing or decreasing by, if b is less than 1, it's decreasing. If b is greater than 1, it's increasing. So this first function has a y-intercept of 2. And so I said this is an increasing function with a y-intercept of 2. So my b would be greater than 1. And then over here, I made a function, an exponential function with a y-intercept of 4. This is a decreasing exponential function with a y-intercept of 4, so b would be less than 1. And last question for the first part of this review, where would you begin to solve question number 13? In a survey of 3,260 people, 57% of people said they spend more than 2 hours a day on their smartphones. The margin of error is plus or minus 2.2%. The survey is used to estimate the number of people in a town of 17,247 who spend more than 2 hours a day on their smartphones. Based on the survey, what are the estimated minimum and maximum numbers of people in the town who spend more than 2 hours a day on their smartphones? Round your answers to the nearest whole numbers. I did this, I think, 2 or 3 months ago, but I'm pretty sure the place I started with was my keywords on this question. Let's see. Yep, look at those highlights. And then I'm going to put my calculator to work. So 50% of people with a margin of error of 2.2%, plus or minus 2.2% to find my minimum and maximum. The total amount of people in the town is 17,247. So that 3,260 was just an extra number. It was just telling me how many people were in the survey, but that's not how many people are actually in the town, so I didn't highlight that. I'm not doing anything with that number. So to find my minimum, I take my 57% and subtract 2.2%. To find my maximum, I take my 57% and add 2.2%, and that's what I did. So to find the minimum, I go on the calculator, 57 minus 2.2, and then I get 54.8%, and then I turn it into a decimal by dividing by 100. So 0.5480 and 548 thousandths by the actual number of people in the town, 17,247, give me my minimum, 9,451, right? My 3 behind my decimal tells my 1 to stay a 1. And my maximum, calculator again, 57 plus 2.2 is 59.2. Then divide that by 100 to turn my percent to a decimal. Give me 0 and 592 thousandths. Multiply that by the number of actual people in the town, which gives me 10,210 and 224 thousandths. Again, round to the nearest whole number. My 2 in my tenths place tells my 0 in my ones place to stay a 0. So I enter those two answers. Make sure you read how the question is supposed to be answered when typing in number answers. Never enter a comma in your answer. That is a hard rule, no exceptions, right? We do not put commas in. only decimals when needed. So we have two integers really here, 9,451 and 10,210. That's it for pages 1 through 7. And let me see if it'll let me give you some codes to practice on IXL. Actually, let me just type here. We'll go all the way across. IXL lessons for pages 1 through 7 in yellow packet. Question 1. IXL lesson YVX. Question 2. Lesson HWM. Question 3. Question 3. Y6U and 5-6E. Page 2. Question 4. I picked lesson LLX in IXL. Remember, to get your IXL lessons to work, you have to already be logged in to Clever. Question 5, lesson 39V. Question 6, LVW and MMB. Question 7, GUP. Question 8, oh, I didn't write one down. I think because I picked that for over here. I think I picked HW8. We'd already done that one in class. HW8. Question 9. An easier version would be N55. And then a little bit closer to the question, 6PC and AW7. Since question 9 was, it was 2 parts, that's why there's 3 lessons to practice. Because IXL only focuses really on one step at a time. And then question 10. BHH. Question 11. SGH. I'm running out of space here, huh? Question 12. 39V, which was the same one from question 5. And then question 13 from the packet was another 2-parter, so I picked 3 lessons for that one. Question 13 your IXL practice looks like 8BS, AF2, and R96. And I know that R96 is one I picked in the other packet as well.